Hello student, welcome to new video of the chapter number 7 from the part 2, that is probability distribution. Right? We have in the last time we have started with this chapter and we have seen few previous example or previous knowledge or revision of this chapter, that how to find out the probability. Right? Probability is nothing but the possibility that we have already seen before this 12th standard. Right? Now, in this new video, we are going to see the proper content from this chapter. Okay? So, the first point in this chapter is random variable. Now, what is the random variable? Let's write the definition of random variable and then we'll see. Okay? So, random variable is a function associating a real number with each outcome of a sample space S of a random experiment, and it is denoted by capital X. Okay, so what is this random variable? The random variable, a random variable is a function. Random variable, it is a function. Random variable is a function associated. It is associated with a real number. It is associated with a real number with each outcome. Right? With each outcome of a sample space S of a random experiment. If you are taking any random experiment like tossing a coin or rolling a dice or playing cards or shuffling the cards, that type of random experiment, and it is denoted by X. So random variable is a function which is associated with a real number with the sample space S or with each outcome of the sample space, and it is denoted by capital X. Right? So this random variable is nothing but X. Okay? That is called random variable. Now let's see the number 2. Vishwanath, क्या है? Okay, so that is the random variable which we denote by capital X. Now we have two types of random variable. Okay, so here we will see the next point is types of random variables. So basically there are two types of random variable. Number 1, first type of random variable is discrete random variable, and number 2 is continuous random variable. Now what is this discrete random variable and continuous random variable? Discrete random variable means the random variable in which the number of elements are finite or number of elements are countable, that is called discrete random variable. I will revise this definition of discrete random variable. The random variable in which the number of elements are finite or the number of elements are countable, that random variable are called discrete random variable. Okay? So what can you give any example where we can get random variable are finite? For example, suppose let X denote the random variable offset number of days in a week. Right? Number of days. So how many number of days in a week? There are 7. Monday to Sunday. These are 7. So they are finite. So that random variable is called discrete random variable. We will take one more example. Number of students in a class. They are finite. So what we can say, it is discrete random variable. Correct? Now number 2 is continuous random variable. Now what is this continuous random variable? Continuous random variable means the random variable in which the number of elements are infinite or the number of elements are uncountable. That is called continuous random variable. Correct? For example, stars in the sky, right? Or the number of drops of water in any river or in tank or anywhere where we reserve water. That is called infinite. Or one more we can take, like the height of the building or the number of floors in the building. We can build uncountable number of floors in the building. So number of floors in the building is continuous random variable. Okay, like this. One more example we can take for continuous. We have seen that stars in the sky, they are uncountable, no one can count it, so that is also continuous random variable. So this is the types of random variable we have: discrete and continuous random variable. Okay, now next thing we have to see is probability mass function. Okay, now what is this probability mass function? Probability mass function means we have to find out the given probability whether it is probability mass function or not. Its short form is PML. Okay, when we say the given probability or given function is satisfying the probability mass function, to verify that function is satisfying probability mass function, that function should satisfy two conditions, right? So what is the first condition? The first condition is that every probability should belong between 0 to 1. Every probability should belong between 0 to 1. It should not be less than 0, it should not be negative, or it should not be extend 1, right? Even 1.1 is also not 1.1 is also not accepted. Okay? So every probability should belong between 0 to 1. And number 2, second condition is sum of the probability, like this. I is equal to 1 to n. Sum of the probability, it should be 1. Correct? Sum of the probability is always 1. If any function is satisfying these two conditions, then only we can say the given function is probability mass function. Okay, for example, we take one example where it's satisfying or not. We'll check it. Suppose we have any probability distribution table like this. This is distribution table. This is x and this is p of x. Then you have 0, 1, 2. Then here you have the probability 1 by 4, 2 by 4, and again 1 by 4. This is the probability distribution table, and they are asking you check whether it is probability mass function or not. So what we'll do, see what is our first condition? Every p of x belongs from 0 to 1. Correct? So if you check first 1 by 4. 1 by 4 is what? 0.25. 0.25 is belonging between 0 to 1. So first is correct. 2 by 4. 2 by 4 मतलब 0.5, right? 0.5 is belonging between 0 to 1. And 1 by 4 is like 0.25, that is also belonging between 0 to 1. So what we can say, first condition, that is every probability is belonging between 0 to 1. So first condition is satisfied, right? Number 2. What is the number 2? That sum of the probability should 1. Sorry, it is Pi, sorry. It is P of x I should do. Every probability we have to add and we have to check whether its sum is 1 or not. So let's add all this probability 1 by 4, 2 by 4 and again 1 by 4. So denominator is same of all number 1 plus 2, 3 plus 1, 4. 4 by 4 is 1. So what we are satisfying? Last second condition is probability of every probability the sum is 1. So the given function this is probability distribution. Because we have distributed the probability, that's why it is known as distribution of probability. So the sum of all probability become 1. So we can conclude that the given function is probability mass function. Okay, so I'll revise what we have seen. Probability mass function. What is the probability mass function? The function which satisfies the given two conditions. First condition is every probability should belong between 0 to 1. So that also we have seen. And the second condition is sum of the probability. Sum of all probability should be 1. So from this example, where x ka values were 0, 1, 2 and their corresponding probabilities were 1 by 4, 2 by 4 and 1 by 4. So what we did, first we have checked all the probability whether it is belonging between 0 to 1 or not, and in second condition we took sum of all the probabilities, and if you are getting their sum is 1, then we can conclude the given function is probability mass function. Okay, and your first point was random variable. Random variable we have seen definition, as well as we have seen two types of random variable also, discrete random variable and continuous random variable. Okay,